Okay, this is January 22nd of 2020. This is a status update on the electric motorcycle. I've taken a 1978 Kawasaki 175 and taken the engine out. I've separately sold the engine and completely stripped down the frame and then started back up from the base frame to create an electric motorcycle. I removed the engine and squared off the engine compartment so that a battery pack can slide in here. It'll be in an aluminum enclosure, a battery box that's currently being made. Here are the batteries. There's 14 batteries. These are actually out of a Nissan Leaf, fairly recent model. The car was probably wrecked. And there's a company that takes the batteries and salvages them. So I have 14 of those batteries. So the nominal voltage is 96 volts and 66 amp hours. So it should be enough to run this motorcycle for probably at least an hour and a half, I'm guessing, maybe even longer, at 55 miles an hour. The rear wheel was replaced by what they call a hub motor, and instead of a drum brake, it's got a disc brake and it's hydraulic brake. So to control the motor requires a very special motor controller. So the combination of the batteries, the motor controller, and this hub motor creates the electric motorcycle. Also replace the gauges that were with the original motorcycle with a electronic display that gives me the speed of the motorcycle in addition to how much voltage I have in the battery, and from that you can pretty much figure out the level of charge available to go. Think of it as the level of gas in your gas tank. So let me just kind of demonstrate then what it's going to look like. There will be a main switch on the gas tank that turns on the 96 volts of the main battery, and when you do that, nothing happens. You can't see anything when you do that. I may have an indicator light that comes on, but I don't think so, because even though that's on, there's really very little current drain. So I think it could be on for weeks and weeks, and you wouldn't really show a big impact on the battery charge. But that main switch has to be on. And then there'll be an ignition switch, which is key, just like a regular motorcycle. I turn that, you'll hear a relay click on. That provides power to the controller and therefore the motor, and it turns on the display that you see up there. Now, so as a rider of the motorcycle, you'll know that there's power and it's ready to run because everything's lit now. And literally, as of right now, you can't hear anything. It's quiet. But it's ready to go, and all I have to do is turn the throttle just like a regular motorcycle. And you can see, Tracy, I don't know if you can show it, but the speedometer is gradually increasing. Just over 45 miles an hour. Now realize it's in the air and there's no load on the motorcycle. No with resistance and weight, but this should go easily 55, 60 miles an hour with no problem. 80 miles an hour right there. Now I don't think it'll go that fast. And I have brakes installed as well. So when you're done riding, turn off the ignition switch. This is the completed electric motorcycle. I have a purpose-built aluminum battery box that holds the batteries. Painted it red, sort of in the image of Tracy's new car, kind of a darker, deeper red. The base is a 1978 Kawasaki KZ200 that completely stripped down and repainted and took all the wiring off because I had to rewire it myself. That was purpose built for electric bike. So it's pretty simple. Turn the master switch on. There's an LED, but I don't have that hooked up yet. And so that provides power to the motor controller, which is mounted in here. And this is the hub motor that is driven by that motor controller. It's a 4,000 watt motor. So powers to that. This is the ignition switch, so I turn that. The display comes on, tells you that it's powered up. And I do have daytime running lights, both tail light and headlight. I have turn signals set up just like the original motorcycle. Brake lights. This is the front brake, which is the original front brake for the motorcycle. And then this is the hydraulic rear brake. That's new. And it's that straightforward. The display is a new electronic display that shows the mileage, the speed, the mileage, and it's got a clock on it. It also shows the amount of voltage left in the battery. So it gives me a rough idea of how much time I have left. And there's no sound, but it's ready to go, because you know it's ready to go because the display's on, and there's a little green light here that shows that the daytime running lights are activated. There's very little regeneration at the moment. I want to test drive it first to get a feel for how much regen I can accept, because when I let off the throttle, there will be some regen if I set it up that way. That's it.
Okay, faster than I turned. Whoops.
So the results. The range for the motorcycle is 42 miles and the top speed 80 miles per hour. Now this was completed in the spring of 2020. It is now 2 years later. I have since replaced the Nissan Leaf 14 modules that you see in the video with 840 Panasonic lithium-ion 18650 cells. The cells are in a configuration of 28S30P, and the results of this change now gives me a range of over 100 miles with a continued top speed of approximately 80 miles per hour.